Howdy, my name is Jim Sinesco and I'm the Vice President with AFC International. And this is a new training video for you that we haven't done some in a while, and I apologize for that, but we finally got a chance to get around to do some more videos. And today I actually have some very exciting news. I'm going to introduce to you some new technology, at least for AFC International, and we'll be talking about the DataNet system, which is a data logging device, and also can be a wireless data logging device, which can be real-time or also remote monitoring, where we can take data from a fixed point instrumentation unit. Like in this case here, I've got a Honeywell paper tape gas detection analyzer. But these DataNet devices are very unique, and they give the ability to connect up using a cable or a wire of some sort from outputs on a gas meter, fixed point gas meter, or it could be portable too. This one's actually a portable type device. And through these inputs, we take the 4 to 20 milliamp signal, and we then take that data and we can convert that to whatever units. And in this case here, this is the Honeywell TLD device used for isocyanate detection. But it takes that 4 to 20 milliamp signal, converts it into part per billion concentrations. So right now we're reading 0 part per billion, and I can easily make sure that that signal is being taken into the DataNet. And then from the DataNet, it then can wirelessly remote send that signal to the receiver module here, which would then be connected up to your computer. And I'll go over these things in a little bit more detail as we get along in this little short video. But again, the whole process is anybody's device, any kind of instrument make or manufacture from anybody. We can now take those outputs. Let me show you what the outputs are on a meter. In this particular one, it's very simple to get to the outputs. Let me grab a pointer here. And those outputs are basically labeled 4 to 20 milliamp. Don't know if you can see that. Let me bring this thing up to you closer. 4 to 20 milliamp inputs. A lot of older instruments, they have it on the little screw connections. Some will be slightly different. But that 4 to 20, you'll see a plus and you'll see a minus. And what we're going to do with those wires, we're going to put 2 wires on it. We're going to run it back to our DataNet device. And on our DataNet device, I don't know if you're going to be able to see this on here or not, but trust me, there is a plus and a minus on these green connectors. So we take the appropriate plus and minus from the instrument to the appropriate plus and minus on the DataNet. And now we're taking that signal, and I can hit this button and it'll tell me, yep, certainly I am getting an input from this device, and it's telling me we're at 4 milliamps. Why is that for? Because our instrument is reading 0. So 0 is 0 always, which is 4 milliamps. And 20 milliamps is going to be the highest range, or the maximum range of your device you're monitoring. The other day I had a Ray Systems PID, fixed PID. That went from 0 to 1,000. So 0 would be 4 milliamps. 1,000 would be 20 milliamps, and all we're doing here is converting that milliamps and separating that out into 16 segments, and we're dividing that range by 16 segments. Now we can get down to a couple of tenths, actually a couple of hundredths, so we can actually get a little bit better resolution in a lot of cases from some of the devices that you're using. So anyway, we take that signal. Now this particular DataNet, this also has a relative temperature and humidity sensor inside it as well. And you don't have to get them like this, but this particular one has that. And that's kind of interesting, because for some of the gases and vapors that we're dealing with, temperature and humidity really plays a very important thing, as we know, right? As far as vapor pressure, is it going to be in the air or not at a certain temperature? And certainly humidity can also give us some key information. So I highly recommend going with a DataNet device that has temperature and humidity. And this particular one is called the DNL 920. Now the 920 series has 4 inputs for 4 individual instruments. So we take 4 different gas fixed monitors or portable monitors, as long as they have that output, 4 to 20 milliamp output. We have 1, 2, 3, 4 all connected up, and temperature and humidity all being sent over to a computer. And that computer again can be hooked up anywhere in your system. It could be a wireless enabled computer, as long as this DataNet can be connected, or this DataNet receiver can be connected through USB port to your PC, you're in good shape. Or it could be a router, a hub, it could be a switch, We can do lots of things now with wireless. So, but for now, we would hook this component up. This is the receiver module. And the receiver module would be hooked up via a small mini USB fitting here on the side. You'll also see a 12-volt power jack that we can run these continuously. Both devices can be run continuously off of a 12-volt little plug-in jack on the wall, so you can go 24/7 with these. As long as your instrument is kicking out that signal 24/7, we can capture that. And it also has, this receiver module has another connection here, basically a relay. This relay can be connected up to a horn or a strobe light or a signaling device to let you know back at your cubicle or back with the computer area or the control area where the computer setup is at, that you have a alarm condition. In other words, as concentrations increase, in this case, this is toluene diisocyanate. If we get an alarm at 5 ppb, we can not only have local alarms from the instrument, in this case the Honeywell, at where the workers are at, but we can also have a signal go back anywhere in the world, but basically on a small system right back to your computer in your office that's running the DataNet software, and it'll alert you, let you know. That software also can be configured to any alarm set point you want, and also can then tell your computer to send out a signal to your cell phone. They're funny how that happened. I just got a call on my cell phone, or a text message telling you that you have an alarm condition going on in your plant. In this case, the toluene diisocyanate monitor is going into alarm and you need to take some action. So all the advances, all the technology with our cell phones, texting, text messaging, we can utilize just by letting this DataNet collect the data and let us know we have a problem. Now, there are many different types of DataNet devices. This one here, the 920, has 4 inputs: temperature, humidity. You can get it without the temperature and humidity. You can get it with just temperature if you want, and the 4 inputs. We also make another device. It's a single. In other words, it doesn't have 4 inputs, doesn't have temperature, humidity. If you want to go to a low-cost option, you can just use that to connect up to any device. So these DataNet devices are very, very unique. Now, the system, a lot of times you get questions, well, how many devices can you totally put on the system, and how is that wireless communication? Is that going to be a problem? We all know at home or at business, sometimes we have problems with wireless devices because you have interference, you have distances issues. Well, any kind of wireless device is going to have those issues. So basically, the DataNet system can handle, this receiver can handle up to 65,000 different devices or inputs coming in. That's a whole bunch. I don't think we're ever going to use that many in gas detection and air monitoring instrumentation. However, we do have that capability. As far as the wireless and the reception and how it communicates, and if we're going to have interferences and distances, you know, like any wireless device, we have to make sure that we're not too far from our DataNet device to our receiver, DataNet receiver. But this system uses what they call a Zigbee wireless transmission system. And this is the box. You can kind of see that, the Zigbee wireless system. What a Zigbee wireless system basically is, it's a mesh network. Mesh networks, Zigbee networks, all work on the principle that each one of these DataNet devices, if you had, let's say, 100 of them throughout the plant, or 20 of them, or 10 of them throughout the plant, not only do they just send and transmit back to the receiver, but they also will find the path of least resistance if that path, direct path, is blocked. Meaning, this device could talk to another DNL 920, and then bounce that signal through a mesh network or a Zigbee network so that it gets back to the receiver. And that's very important. Our modern internet works on the same type of mesh network, Zigbee type network, very similar. If one path is closed, it goes and tries to find the fastest way to get that information back to the receiver. So very, very reliable, very, very good system here for data collection. The other thing that makes this really important, especially for health and safety type devices, and this is why I really like it, being a safety engineer, I really like this, is that even though we lose connection with our receiver module, let's say we're connected up here to this device from this toluene diisocyanate detector. Very important, very unsafe situation. We have high levels of isocyanate. We got to know that. We need to alert it. We also want to make sure we data log that information. But even though we lose connection through the day, this data logger is independently taking that data and keeping it here. And all that data is residing here on a data logger, basically like a memory stick if you want to think of it that way. When the connection does come back, then the DataNet logger will send all that information back on over to your PC and your communication. So a perfect application would be, hey, I want to be able to take this system, use my laptop, but I want to take my laptop with me, but I still want to do data logging and controlling and watching that information. Let's say you're a consultant, an industrial hygienist, you want to do a survey. You can put these DataNet devices out. When you're there at the plant, at the site, you can have it connected up to your laptop or your PC, see what's going on real time. At the end of the day, you can disconnect your receiver module from the system. These will still be connected, these DataNet loggers still connected to your device. You go home. Next day or 2 days or a week later, you come back, you fire up your DataNet receiver with your laptop. When you turn it on, it will automatically go find everything, all the other DataNet systems in the plant, and then that information will then be called, and this receiver module will then be pulling that data, that stored data for the week or day or night or whatever the time period is, back into your receiver. Now, we'll take a little bit of time depending on how long you go. You're away from the plant, but all that data is still retained. It can still be sent back to your main computer. This can also be done through the internet and through hubs and through wireless systems as well, more advanced systems, and we can talk about that another time. But really cool technology. This has been around for a little bit. We did some systems for a couple of local state agencies here, utilizing remote monitoring, utilizing many types of inputs in a residential home with some issues with infiltration of CO2 and natural gas into a home. But we can virtually take any signal, any safety and health application whereby you're doing fixed point monitoring or portable devices that have outputs, and we can log and watch that real time from pretty much anywhere in the world, and be able to watch and log and alert people to take action. Again, new technology, great new stuff for AFC. We're really launching this product. It's called the DataNet system. The DataNet, again, it gives you the DataNet logger, DataNet receiver. We can log the information from any device out there. If you have any questions on this, you can give us a call at 800-952-3293, or check us out on the internet. You should probably are already, www.afcintl.com. And again, thank you for watching.